All right, in this video, we'll be talking about compound angles. We've spoken about the basic identities in one of our videos. And in this particular video, we want to be talking about a different set of identities, trigonometric identities. Uh, Understanding trigonometric identities are quite very simple. We already dealt with the first 7 basic identities. But in this particular video, we want to introduce a new batch of identities which we can all see, and we categorize these particular identities under what we call compound angles. And one of the ways you recognize compound angles is that you'll be having the sine or the cos or the tan of different two different angles, either being added together or being subtracted. For instance, we can have, these are examples of compound angles. Imagine we have sine x plus pi over 4, for instance. So when you see questions like this where you have the sine of a particular angle plus another different angle, it could be in different formats. It can come in different ways. That's categorized under compound angles. So what we're going to use to represent the basic theory around compound angles for this particular video is A plus B. So A will represent the very first angle, while B will represent the other angle. So in the case now where you have the sine of an angle A plus another angle B, the result of that, using our identities, will be the sine of the very first angle times the cos of the second angle, plus this is one entity, then this is another different entity. So what you have is the sine of an angle, the first angle, the cos multiplied by the cos of the second angle plus the cos of the first angle multiplied by the sine of the second angle. So what you have to do basically in this situation for this particular side of things is to cram all this. So you need to note all this depending on the exam you're taking. If they're going to be providing this for you, then you don't need to memorize it. But if not, you have to try and memorize it. Obviously, you can notice the pattern around things. When you were dealing with sine, what you had was sine A, sine cos plus cos sine. For sine A minus B, it was sine, the same sine cos minus cos sine. This was minus. But when you're dealing with cos of compound angles, you are dealing with cos minus sine. And then the same thing goes for the subtraction cos plus sine. You can notice that for cos, you have, when it was plus, it was minus that was separating the result. When it was minus, it was plus that was separating the result. So you can find a way to make all this into a format that would make it easy for you to easily memorize it. And then when you see the tangent of compound angles, you can see that what we had was tan A plus tan B divided by 1 minus tan A times tan B. And when it was minus, what you had was minus here and then plus here. So this is the different compound angles we'll be dealing with in this particular video. And from many of these compound angles, from these compound angles is where we're going to be deriving our double angles, which we'll be sharing a video on that very soon. Now, look at a simple application of a compound angle. You are told to simplify sine A minus B minus sine A plus B. Now, I will need to clean up this place, so I hope you have this somewhere. And we'll be using this space to solve this particular question. So, of course, you can see we are told to find sine A minus B. So what we can just do here is go on to fix this whole thing. This is sine A minus B. So we'll fix this whole thing here. And then for sine A plus B, we'll fix this whole thing there. So that's the way you solve that. And we'll be solving more different examples apart from this. So if you fill this in, what you have is, of course, this will be sine A, fixing A minus B in sine A cos B minus cos A sine B. You can fix this in a bracket. This is for the first part, minus, I love to use my bracket very much. Then sine A plus B will be sine A cos B plus cos A sine B. So this is what we have initially. You go on to open this. Of course, this will be sine A cos B minus cos A sine B minus now, because the minus will open both of them, minus, that is the essence of using your bracket. Now, minus times minus will be minus here, cos A sine B. So if you look through at what we have here, we can see sine A cos B here, we can see sine A cos B here, but there's a minus here. So this is plus sine A cos B, this is minus sine A cos B. So these two will actually cancel out, and then you'll be left with minus cos A sine B minus cos A sine B, which is the same thing. So when you do that, you'll be having minus 2 cos A sine B, which will be the final answer. We cannot dissolve this any further. So that means we have been able to simplify this particular question to resolve to this particular answer, and that will be all. So let's solve some more examples quickly. All right, look at this question we have to show that the tangent of course, this is a compound angle here. I told you when you have situations like this, when you're adding or subtracting two angles together, this is another compound angle. This was the compound angle. We'll be using the application of the compound angle for tangent when we had addition, and for this we'll be having that for when we had subtraction. So what you have to do is to go on and reflect back on your compound angles, then fill them in. So let's try and solve for the tangent of x plus pi over 4. So from our compound angles, we know that the tangent of the addition of two different angles, for instance, we have x and pi over 4, will be equals to the tangent of the first angle. In this case, that's x, plus the tangent of the second angle. In this case, this is pi over 4, all over 1 minus, according to the compound angle identity, the tangent of x times the tangent of pi over 4. So we are using exactly what we had in our compound angles. In that case, we had, in the initial one I showed you, we had a plus b. So when we reflect on that and use our a as x and our b as pi over 4, this is what we're going to get. So what we can do right now to solve this particular question is to remember that if we're dealing with tangent of x over 4, tangent of x of pi over 4 rather, don't forget this, when you see the word pi, we are more like dealing in radian, so you can easily convert that back to degree. Don't forget that 180 degree equals to pi radian. So in this case now, we'll be having tan 180 over 4, converting it back to degree, and we'll be having tan 45. Tan 45 will be giving us the value 1. So obviously, I can bring my solution here. That means my tangent of x plus pi over 4 will be equals to tangent of x plus 1 over 1 minus the tangent of x times 1, which will obviously still remain as tangent of x. So this is where we are able to dissolve our very first value 2. So let's go on to solve for the other side. We have solved for tangent of x plus 4, x plus pi over 4. So we have to do the same for this, and then we'll multiply the two answers together, and let's see if we're going to arrive at what we're told we're going to arrive at. We're supposed to show that the multiplication of those two gives us minus 1. So using the compound angles identity for when we had subtraction of two compound angles dealing with tangent, what we're going to get is the tangent of x, in this case, minus the tangent of pi over 4 divided by, now in this case, it's 1 plus. This is based on our tangent identity. So you can see what we have here. This is us just filling in our values for x and pi over 4 into our compound angle identity when we had the subtraction of two angles. And this is what we're going to arrive at. So going on to dissolve this, don't forget now our tangent of pi over 4 will be 1 because we have proven that pi is, of course, we know pi radian is 180 degree. So 180 over 4 will be 45, and then we have tangent of 45. So we can finally arrive at this answer as the tangent of x minus 1 over 1 plus the tangent of x. So now we have been able to get the two values for our tangent of x plus pi over 4 and tangent of x minus pi over 4 as what we have here. So we're going to be multiplying these two values together. That is this value multiplied by this value. And let's see what we're going to arrive at. So that is, we have the tangent of x plus 1 divided by 1 minus the tangent of x multiplied by, we have the tangent of x minus 1 divided by 1 plus the tangent of x. So this is what we have, and we want to prove if these two values here will be giving us minus 1. So you can see what we have here. We can see that when we have tangent of x plus 1 and 1 plus tangent of x, both of them we can still rewrite this as 1 plus tangent of x. We're not wrong. 2 plus 1 and 1 plus 2 is still the same thing. So, and if we're able to do that, one of the things we will be able to see is that these two values can cancel out. Don't forget there's a multiplication sign here because we are multiplying them together. So the two values right here can actually cancel out. This can cancel out, and we'll be left with tangent of x minus 1 over 1 minus tangent of x. So we'll be left with tangent of x minus 1 over 1 minus tangent of x. So if we decide to factorize minus outside here, that means if we decide to bring out minus sign, like minus 1, we will be able to write this as 1 minus tangent of x. If you understand what I'm doing here, minus times 1 is minus 1, minus times minus tan x is still tan x. So we're factorizing the minus out, and we'll be able to arrive at what we have here for the numerator. But if you look at the denominator, it's the same thing as what we have been able to factorize out in the denominator. So, all right, so you can go on to cancel out 1 minus tan x and 1 minus tan x. So this will give me the final answer to be minus 1, which was the original answer I was told that I should arrive at. So you can see that we have been able to arrive at minus 1. So we've been able to show that the multiplication of these two compound angles will give us minus 1. Let's see another example very quickly. So we have this particular question. We're given that the cos of an angle x is 0.40 and the sine of an angle y is 0.71. And we're to evaluate now. In this case, we are supposed to use the compound angles to find sine x minus y, cos x minus y, tan x plus y. So this question is quite simple enough. The very first thing we have to remember is our identity. So in solving for sine x minus y, we can see this is a compound angle for sine when we are subtracting two angles from each other. And from the identity I gave earlier, you can see that this is going to result in sine x cos y minus cos x sine y. So this is the identity for sine x, for sine of an angle minus another angle. This is what we're going to have. Now, looking at the question we're giving cos x, we're giving sine y. So we have this particular value for cos x. This was told in the question already that this is 0.40 and sine y is 0.71. But we're not told the value for sine x and the value for cos y. So we have to go on to initially find what our sine x and cos y will be. And we can easily get that from what we know already. We know that cos x equals to 0.40. So the first thing to find is what is even our x value. So we can get our x value from here, and then we can go on to then find sine x from our x value. So obviously our x value will be the arc cos of 0.40. So the arc cos of 0.40 will be my x value. So, and if you press this on your calculator, you will get 66.42 degree. So we have 66.42 degree as our x value. So we can then go on to evaluate for my sine x. So my sine x will obviously now no longer be just sine x. We can easily write sine 66.42 degree. So you can go on to find the sine of 66.42, and we're going to arrive at 0.9165. 0.9165. So we can go on to find for our y, because we also need to find cos y, and we have been given sine y. We've been told that sine y was 0.71. So we need to first find the value for y, and our y will be the arc sine of 0.71, which will give me our y value as 45.24. Now we can then be able to find our cos y from here. So my cos y now will no longer just be cos y, we'll be having cos 45.24. So the cos of that will be obviously 0. If you press this on your calculator, 0.7042. So this is how we have been able to find our sine x and cos y from the values we were given previously. So from here we can go on to then evaluate our sine x minus y using this compound angle identity. So that means we can say sine x minus y in this particular case will be equals to the sine x value. This is it we have here. That will be 0.9165 multiplied by cos y, which is what we have here, 0.7042, then minus cos x was given already, 0.40, and then sine y given as 0.71. So if you press this on your calculator and evaluate the entirety of this value, you should arrive at, so what we are going to get if we multiply this particular value here with this particular value is 0.6454. And for the other side, we have 0.40 times this 0.40 times this will give me 0.2840. So what we have to do now is to subtract this side from this side. That'll be 0.65454 minus 0.2840. And this will give me the final answer to be 0.3614. So this is the final answer for my sine x minus y. So we have been able to solve question number A. You can go on to solve question number B. You can pause the video and go on to solve question number B. So for question number B, we have the cos of x minus y. And from the identity, the compound angle identity, we can write cos x minus y as cos x cos y plus sine x sine y. So don't forget, we have already gotten the values for my cos x. We have the cos x given, so that's obviously going to be equals to 0.40. The cos y, we arrived at it as 0.7042, and we know our sine x from our previous work we did to be 0.9165, and then our sine y is what was given initially in the question as 0.71. So going on to solve all this, you just need to punch this on your calculator and you will arrive at the final answer. So if you multiply those two values together, you will arrive at what you have right there. And what you need to do next is to make the addition of the two, which should give you a final answer of 0.93. Actually, you're going to get 239, which can be shortened to 0.9324. So this is how you make use of the compound angles. This is our final answer for question number B. And what I'm going to do is I'm going to leave question number C for you to handle, and that is the tangent of x plus y. So I can also tell you, I think I should also add to that, you can get your hands dirty by trying for sine x plus y. You can also try for cos x plus y, and then you can also try for tan x minus y. So this will help you to understand the compound angles, to be able to apply the compound angles on several questions, which will make you much more better using the compound angles. All right, guys, thank you guys for joining. I hope to see you in the next video. Bye-bye.